In this video, we are going to show how you can use Design X to do some basic inspection. Now, normally people don't think about Design X as an inspection tool. As you may know, Design X is the most powerful and most widely used reverse engineering software. And it's primarily used to take 3D scan data, like you see here, and create CAD models. But for some customers that want to do some very basic inspection, this works fairly well. And I'm going to go through in this video and just kind of show you some of the basic things you can do with Design X. Now, keep in mind, this is not a replacement when you start getting into hardcore inspection and GD&T and datum alignments and measuring back to CAD. But we have a lot of customers who want to scan something and measure it that have no CAD. They're not doing GD&T. They just want to be able to pull basic dimensions from the scan data. Now, some scanners have some tools in the scanning software to do it. In this case, we're just going to show you how to do it in Design X. And we're going to use Design X Go, which is the kind of, I don't want to say basic or entry level, but it's the first option available. There's Go, there's Plus, and there's Pro. And we've got a video that breaks down all three of those modules, and you can look at that. But I figured I would show it with Design X Go just for somebody who's looking for the most affordable way to maybe do some basic inspection. So let's get started. This part, if you've seen any of our videos, you've probably seen this part before. It's a casting, and we've got some scan data here. So we're going to walk through now and just kind of show you some of the things we can measure and how it's done using a few different methods. Okay, to start with, let's do some basic measurements, just some maybe overall. So, for example, if you look here, this face is on an angle over here. So maybe we want to know what the angle of this face is. So the easiest way to do that is throw up a couple planes and measure between them. So in Design X, I can click the plane command. And then I like using this tool here. I click with my button, and then as I start to slide up, it looks for similar curvature. And you can see it's going to fit a plane through everything that's turned this teal color when I stop dragging, okay? And I'll say, okay. So you can see we fit a plane through there. And now I'm going to do the same thing over here. And hit okay. Okay? So now we have those two planes right here, okay? So now I'm just going to come under the measure tool, and I'm going to say measure a distance, and I am going to go between two planes. Actually, we don't want distance. We want angle. So let's go measure. So you've got distance, angle, radius, measure section, and mesh deviation. That's when you're measuring between two meshes. So we are going to go to planes, and we're going to pick this plane and then pick this plane. And you can see we're going to get an angle. Now, there's no reporting tools in here like you would normally do in a normal system. But what we can do, let's go to a view here, is we could just take some, like if we wanted to make kind of a report, we could take some basic screenshots and then save them for later. So let's do that. So all right, so I'm going to say print screen. And again, we'll just grab the area we want to keep, save as, and we can call it whatever we want. I'm going to call this angle measure, and we'll save that. Okay, so we've got that saved. Now, so basically we can go around. Let's just do a couple others so I can turn off that dimension. And so we've got that angle. Let's do a couple distances, right? So let's say we want to know the distance from this top plane here down to the bottom plane, right? Well, we've already got this main plane here. So all I need to do is come in, and we're going to do measure distance. We're going to go plane to point. This will be in the, I believe, Z direction. Okay, so what that means is we want to lock it down to that axis. Okay, so that it's following the Z. Okay, we'll flip this way, get it into a view we like. We'll say okay. And again, we'll snap a screenshot here and call this, dimension, whatever we want to, whatever names we want to give this stuff, just so we can remember it. All right, so let's just do one more. So we'll turn that dimension off. And let's say we want to measure the inside of this, right? Because it's critical. Hide that plane there. So again, we just create a plane. And theoretically, we could just measure point to point along an axis. But at least this way, you're averaging the plane on one side. So we'll just click here. Enough of that there. Hit OK. And we'll go ahead and do that measurement again. So we're going to measure distance. This time looks like along the x-axis. We will do plane to point. So pick that and then pick there and hit OK. And, whatever view you want to take this in here. We'll again take a screenshot. Call this, whatever we want. Let's call it dimension 5. Okay. So, you can measure that. And again, like I said, you could just pick, theoretically, you don't even have to create the planes, right? You could just come in here and say measure distance, pick the axis. So let's go back to that Z for a minute. We can pick a point here and then just pick any point here. Okay. So, that'll work too. Okay, so, again, this is no different than you'd measure something by hand, right? So let's hide that. So basically any planes or angles, we could go in here and measure. We can also measure along a section. We can measure radius, but I'm actually going to show those a little bit different here. So what I'm going to do is I'm going to go to Sketch, and I'm going to go to Mesh Sketch. And let's start on this bottom plane. That's the front. We're going to pick that. Now, if you don't know what a mesh sketch is, normally for reverse engineering, you use a mesh sketch to cut through the data, to cut through the scan data, and then you build your CAD. We're going to kind of do that, but we're going to do it really just to measure stuff, right? Now, I want to move this down. You don't want to sample right here at the bottom because you can see it's literally on the bottom of the part. There's also a little bit of a radius, or actually a chamfer on there. I'm going to go just below that. I don't want to go too far in case there's draft on this part. This part is cast and then machine. So what you end up with is this section through the part. Now, the outside of this part is rough cast. It's probably not critical, but let's just say we want to measure it anyways. So what I can do, it's kind of broken up because it's probably not a very smooth circle, but I can sample some of the segments and it'll keep adjusting this circle because now what we have in blue is a perfect circle fit all the way around there. Now, once we have a piece of geometry, we can add a constraint to it. And in this case, oops, not a constraint, sorry. We already know it's a circle. A dimension, and throw a radius on there. And I'm going to hit OK. And if we want, we can show the mesh. And again, this is all just for our picture. And I'll pull this up. And again, you're not going to have tolerances on this. This is no different than, just measuring something by hand. But you can do it certainly easier because, trying to measure this circle by hand is tough. It's A, it's pretty big, and B, it's hard to, where would you measure it from? Okay. So there's that. And then I'm just going to get rid of this because I don't really need to keep that geometry. And let's say we want to measure now an angle between one of these holes and, and let's say horizontal. So there's a couple ways we can do that. Actually, let's leave that circle here for a minute, and I'm going to draw a line right at that center, and then I'm going to see how it, the little box shows up there that tells me I'm horizontal. Okay, and let's just fit a circle through, this one here, and now I'm going to draw another line through the center and right there, okay? So once I have those lines, now I can get rid of this. I mean, you theoretically could leave it. I could get rid of the circle if I don't want. Let's leave the circle, just maybe it's good to have. And so now I'm going to throw a smart dimension on here, and that'll give us that angle, okay? So theoretically, you could do that for all these holes, right? Any geometry. So all I'm doing is really sampling through this geometry and then dimensioning it, right? So let's do another screenshot. Save this. We'll call this whatever we want to call it. Nice thing is we have visuals later if we need to see them, okay? So you can do that. Now let's go back. Let's get rid of all this. And I'm actually going to, let's say we want to measure, well, let's do the inside circle. So let's do this. Now this one should be easier because it is probably machine data on that inside. So it's going to be much easier to measure that. And that's probably more of a critical dimension. So let's grab that one. Okay. And what I'm going to do now is I'm actually going to leave this one here because let's say I want to measure to see if this bottom circle and let's say this top inner are concentric, right? So let's just leave that geometry. You'll see why in a minute. Now I need to create a plane up here at the top. And when I do that, I want it to be parallel to this plane down there so it's not skewed. So when I go to plane, this time I'm going to say definition. I'm just going to pick a point up there. And then my normal will be this plane here. So basically they're locked in. Okay. So now I have that plane. So now I'm going to do the same thing again. I'm going to say mesh sketch. I'm going to pick this plane. I'm just going to sample down in a little ways and hit OK. Now the other sketch, okay, the other sketch is still shown, right? So you can see that circle, that dot right there. So watch what happens when I pick a circle here. And if I zoom way in, you can see they're pretty close to each other, right? Now, if I want to measure between them, let's try coming in and let me see if I can, maybe a couple ways I have to do this, but let's just try this. So you can see it's a pretty small amount. If I go measure distance, I go no alignment, and I just go point to point. Yeah, it will let me pick those. Okay. No, wait, we do want to lock that in an axis. We want to lock that in the, let's do the X. And let's redo that. And let's pick 2 points. There we go. So at least in the X direction, and then we could do it in the Y. We know they're out by 0.0, basically 58 microns. So I'm not going to bother snapping a picture of this. So let's do the same. I'd maybe write this down if I wanted to. So let's do the same thing again in the Y. And they're out by about 60, 66, right? If you try to measure them across, because these points in 3D space are real far apart, that's why I was getting that. Now, I could go back and actually project 2 points onto one of the planes and then do a measurement that way if you really wanted to. But you get the idea, right? So if I want to see how close they are, how concentric these two circles are, again, and if you were to try to measure this by hand, how would you even do that? Okay, so that'll show you how how concentric two pieces of geometry are. All right, so let's say we want to measure flatness on something. Well, there's a way we can do that by actually modeling. So let's go back to our planes, turn on that top plane, which we know is sitting right there. And I'm going to go into sketch. It doesn't matter. I can just use normal sketch. I'm going to pick. Then I'm just going to draw a rectangle and just something a little bit bigger than that bottom. And then I'm just going to get rid of 2 of the lines because I just really need. And then from here, I'm going to create a surface. And I can either loft or extrude. They're both going to work because I'm just creating a flat plane. Okay, so now I've actually built a planar surface, right? So now I can come in here and I can say accuracy analyzer and do a deviation analysis. And it's going to show me. So first of all, let's crank up our resolution, i.e. make it lower. So let's go down to 20 microns. And then let's crank up our resolution on here. And what we end up with is a kind of a color map. Let me turn off that plane for a minute. Okay, and it might be a little hard to see because of let's adjust our range here. Oops, no, let's make this like 0.25. Let's see how that looks. Okay, so it might be a little bit hard to see because as I highlight over, but so, and you can see I can basically it's measuring the scan data to the CAD data. So you see these bigger spots, those were some stickers. They weren't targets, they were just little round stickers. Obviously those are throwing it off. And then there's some holes in here, but you can basically see how flat this is. So, everything in green is within 20 microns. Everything here you can see is 30. That's obviously way over. Okay, so we get a good idea of how flat the bottom of this part is by doing this. And we can, again, take a screenshot. And we'll call this our flatness measurement. We'll call this flatness, okay? So just kind of a cheap, easy way to show some flatness, okay? But if I do measure distance, and we did do that, that'll be in the Z. And I pick a point there, and then I pick the plane. Essentially, you're going to get the same thing. So now let's see if I turn the mesh off. Yeah, there we go. So now we can see that point. And now I could do a screen grab. So you could create a bunch of those if you wanted to. And I'll call this flatness 2. Okay. So there's a way you could do flatness. Okay, so how about something like, cylindricity, right? So let's take a look at this, right? So one of the things I can do is I can fit geometry through this, right? Now I probably don't have a perfect way of making sure dimensionally the cylinder's in the right spot, although you might be able to move it. But let me show you this. So we're going to come in here and we're going to say cylinder. We're going to, we got to do this first because it's looking for a region group. So let me come in here first. I'll explain what I'm doing. I'm going to select that area using that select tool. Then I'm going to come under region. I'm going to say insert, right? It's going to just paint that and identify it. What a region is just, if I highlight over, you can see it says cylinder, right? So now I'm going to come in here and I'm going to say surface primitive, cylinder. I'm going to pick that. You can extend it if you want. We really don't need to in this case. And it's going to fit a perfect cylinder through there. Okay. And turn that cylinder on. Let me turn that bottom plane off. So now I have that cylinder, and then we can do that deviation analysis again. Okay, so you can see, and we'll keep the same tolerances. So you can see in this area, it's off by 40, 48, 50 microns. Up in here, it looks pretty good, right? So now the only thing to keep in mind is what I was alluding to is that cylinder is just best fitted through there. We're not measuring where the axis of the cylinder is in relationship, although I think that's something we can do, and maybe we'll try that out. And knowing this is on an angle, right? But let's just stick with this for a minute. So we could have this here. It's hard to see with the mesh on, so let's do that. And take a screenshot here. And we'll call this cylinder, okay? But it at least shows you where this is. Now, so you can kind of see that, yeah, down in here, this thing is not a perfect cylinder. Because again, we fit perfect geometry through there. And obviously the mesh is not perfect down in this area. So let's go ahead and fit a vector through that same area, and then we'll measure that. So we're going to come here and say vector. We can just, we're going to say cylinder center, and we're going to pick that. And we do not want an axis constraint. We just basically want it to find the center. Okay, so now we have that. And now let's turn on, I believe that'll be our front plane. Okay, and let's see if we can now measure. That'll be an angle, and that will be a vector to a plane. So we pick that, and there we go. Now, another cool thing we could do to just kind of make it visually better, let's come in here and say View, Clip. We're going to want the X and flip it around. And we could kind of, put this about right there. If we wanted. Actually, let's go and rotate the view, right? So you could have something like that. So that's that axis right down the center. We can turn off that region if you don't want to see it. And so now we know, we'll call this whole angle. Okay, so let's say you want to know the exact X, Y, Z position of a point somewhere for whatever reason, right? Sometimes with parts that maybe mount in fixtures or something like that, right? So if you turn on your top, front, and right planes, that's our origin, right? So in this part, we haven't really identified it. I mean, we can move these, we can assign the front, right, and top to be wherever we want. But let's just say we want to know from that origin, one of these holes. So what I'm going to do is let's turn on the plane. Should have a plane, yeah, right there, right? Right there, okay. So this plane's up on the top, and, let's say we want to know that hole. So I'm going to go to Mesh Sketch. I'm going to pick this plane. I'm going to sample down in just a little bit. And it doesn't really matter which hole. I'm just going to, you can see these holes have a countersink to them, right? So I'm just going to put a circle right there. That's going to give me a center point. And if I pick there, you can see it's going to give me, now this is relation to the plane. So now let's go to point, and I'm going to pick that point right there. And if I just pick it, you can see here is the XYZ. So the other one was just kind of in a 2D plane, right? So let's just say for some reason you needed to know where this point is. Turn off that plane there for a minute. I could, again, just pick on it. And I'm going to just do a screenshot and just grab this here. You could, manually key it in or something like that if you wanted to. But let's just call this 0.1. So if you needed to know the exact X, Y, and you could do a whole bunch of these if you wanted to, but if you need to know where it is in relationship to, the coordinate system, that would be one way to do it. All right, so let's do maybe just like a cross section through the part and pull some measurements. So instead of here, so let's do this. Let's turn on our planes, and let's just take this top plane here. And let's just say, well, it's not quite centered. So let's do this. Did we keep all that geometry or did we get rid of it? Yeah, so, okay, so we still have this sketch. So let's say we're just going to cut it right through the center of the part. We're going to use that. So we come to plane, definition, position is going to be there, and the normal vector will be there. Okay, and we've got a plane right through the middle of the part. So now we go to sketch, mesh sketch. We've got that. So basically like a cross section through the part. Let's hide that. And now we could come in here and measure anything we want, right? So kind of a sectional view. Now, to do that, I have to build some geometry, right? I just can't measure from here to here without building something. But that's okay. So let's hide that. So what I can do one of two things. I can just, wrong command there. Use this. I can say, fit align. and fit a line. Now watch what happens though. Let me show you something. If they're not in this case, if they're not vertical, I think it's going to try to measure an angle, right? So if I pick here to there, yeah, see how it's trying to measure an angle because they're not parallel, right? So what we have to do, delete that. Well, actually, we don't need to delete that. Just double click it, and we're going to make it vertical. And we can just also right click and say vertical. Okay. So, we're going to make them vertical, even though they're, if you really, really, really zoom in, yeah, they're not. But again, if we want to, but down here, it's fairly. So, we're kind of averaging it, right? But now I could come in here and say, now we can measure from here to here, and we can throw a dimension on there. And we're going to do the same thing down here. Now, one of the things I can do is if I turn off this fit polyline, and when I draw it, that's going to want to snap to it. That's okay. We'll just go ahead and do that. And that. Because it's always fitting through the scan data. And most manufactured parts, are not perfect. So it's always trying to fit through that. So we just have to go in there and correct that. So we'll measure here to here. Maybe we want an overall. So let's throw a line here and throw a line. And we can grab this and hold the shift and grab that, and it'll grab both. And this we will make horizontal. This we will make horizontal. And we're going to throw a dimension here and here. Okay. So whatever you want to dimension as like a cross section through the part. You could do an angle. Here, let's throw an angle on here too. And we will go from here to here. And let's just throw that in there. Okay, so good enough. Then again, I'm just going to screenshot this. And we'll save this as, section view. Okay. All right, so you get the general idea here. So we can just exit out, bring our mesh back. And maybe for our inspection report, let's kind of hide all this other stuff and just put the part in kind of a nice view like that. And we'll take a nice snapshot for our cover page. Save as, and we'll just call this parts. And, if you want to do a front and top and, all your different views of the part for your report, make it all fancy, you could certainly do that. But basically, you get the general idea. So between the measuring tools here, which will just measure points or use, planes and so forth, and then really cutting sections and just kind of fitting geometry through it and then pulling dimensions, you can do some basic inspection. And again, this would be no different than measuring something by hand. Now, if you, but it's also, what's nice about this is instead of using let's say an arm-based system or, something more like a tracker where you can't start taking your measurements until you establish coordinates and then you can't move your part. So for example, if I want to measure this angle to this angle, well, I've got to kind of lock the part down. I've got to establish where X, Y, and Z is. Then I've got to sample some points here. Then I've got to sample some points there to get that angle, right? Well, with a 3D scanner, you just scan the part because we will establish all that here in the software. So we're not locked down. We can freely move the part around. So it's much easier because you do all the measuring later. You establish your coordinates later. So this part we can scan in a couple of minutes and it's done. So, and then you can go offline and do all these measurements you want to do. So next, what I'll do is we'll whip up a real quick report and I'll just show what that looks like. Okay, so I just took all our pictures and I just whipped up a real quick inspection report. You could build a nice template, have all your part information here, customer, revision, date, inspector. You could put all that here. There's just a nice screenshot of the part. Here's a couple of the dimensions. Now, You can adjust the size of the font for those kind of 3D dimensions. I probably should have done that ahead of time. But you can see it here. We've got, whatever dimensions you have. Here's a radius dimension here. Here's another one there. And again, you can label these by feature or whatever what they are. Here's one of those angle dimensions. Here's that other 3D angle dimension. Here's our cross section through the part with some measurements. Here's that point, which we're calling out here. Now, again, you could clean this up, get rid of all this other stuff and make it look fancier, but whatever. Here's our flatness with just the measurement there. Another thing we could have done when we did that is, let me just show you this real quick. If I can go back to that plane, let's turn that plane back on and let's do that deviation. What I like to do, let's put this kind of over here, is let's just put it here. And then this time we're going to capture the color bar. That way you can see. So let's just, this case, I'm going to say copy to clipboard. And let's just delete that one and paste in this one, right? So there, now you've got that that color bar for reference, okay? And we could have done the same for this one. I'm not going to bother doing both. But there's our cylindricity. There you can highlight it. So again, a customer can look at this and see, the value range, right? So everything in green is within our tolerance range. Everything in red is in the plus and blue is in the negative, okay? So again, and then I can save this as a PDF and share it with a customer. So, it's just a quick way to, be able to make some basic measurements. So really the primary customer here would maybe somebody that already has Design X. Maybe they don't do a lot of inspection. Maybe they don't have an original CAD file to measure to. They primarily do reverse engineering, and they want to measure it. So you can quickly scan a part and then just pull these manual measurements, like I said. And again, there's no GD&T here. There's no datum alignments. Although you could kind of do that by building some geometry and measuring to that. But let's keep this simple. You don't want to invest in some other inspection technology or a CMM or something like that. So again, we'll just wrap this up, but I just thought I'd show. And again, this is in Design X Go, the basic version of Design X. You can pull all these dimensions and build some basic reports when you want to be able to just scan some parts and take some basic measurements.